Perimeter is often tested in abstract ways on the ACT math exam. So in this video, we're going to review a bunch of different types of perimeter problems so that you can become more comfortable with different ways in which perimeter may be tested. Find the perimeter of the triangle below. So we're given a right triangle with side A and side B of measure 3 and 4. We're not given side C or the hypotenuse. So in order to get the perimeter, we should calculate the hypotenuse. We can do that by recognizing that it's just 5, or you can very quickly use the Pythagorean theorem. Either way, you'll end up with 5. So to get the perimeter, 3 plus 4 plus 5 is 12. Find the perimeter of the shape below. Alright, it looks like we're given a very clear width of this shape, which is 6, and we're given 3 different segmental lengths of the height. So we get 2, 3, and 2, and if we add that up, that's 7. So if we add those 3 segments together, since all of these are right angles, the total height is 7. So we have that, and it looks like we have 3 measures of widths that aren't labeled, but again, since we have all right angles in this, we can just add up all of them and we'll get 6, even if we don't know what each individual value is, since the overall width is 6. So we should be able to add up 6 times 2 plus 7 times 2, which is 12 plus 14, or 26. Find the perimeter to the nearest tenth of the trapezoid pictured in the coordinate plane below with vertices A, B, C, and D. Since this is in the coordinate plane, and all of the vertices are very clearly labeled with integer values for points, we should be able to measure the length of the base and the other base by just counting the number of units. So the top base is 1, 2, 3, 4, 5 units long, and the bottom base is 1, 2, 3, 4, 5, 6, 7, 8 units long. Alright, now we need to calculate the lengths of AD and CB. So let's actually draw in a right triangle right here, and we'll use the Pythagorean theorem to solve for the length of the hypotenuse. So we have a base of 1 and a height of 2. So that is 1 squared plus 2 squared is equal to our unknown, or c squared. So that'll end up giving us the square root of 5 for the length of AD. For the length of CB, if we draw in a right triangle, we end up having a base and a height of 2. So that ends up being an isosceles right triangle. So that means the hypotenuse is going to be 2 times the square root of 2. So if we add all of those lengths up, we have 8 plus 5 plus the square root of 5 plus 2 square root of 2, which is approximately, rounding to the nearest tenth, 18.1. The perimeter of a rectangular octagon is 32. What is the length of its sides? Well, an octagon has 8 sides, and it's regular, meaning all the sides are the same length. So that means we have 32 divided by 8 to get the length of each individual side, and that is equal to 4. The area of a rectangle is A times B. What is its perimeter? So if we have a rectangle, and we have sides A and B, then that'll give us the area, A times B. So its perimeter is simply going to be, so we have an A on that side, and we have a B at the bottom. That'll give us 2A plus 2B, and that will be the perimeter. The area of a rectangle is 20 square feet. What is the perimeter of the rectangle? Alright, so we don't know any of the lengths of the sides. So for all we know, one side could be 5 feet, one side could be 4 feet, one side could be 10 feet, one side could be 2 feet. Since we don't know the lengths of the sides, we actually don't have enough information to figure out the perimeter. If they gave us the value of one of the sides, we would be able to figure it out, but since we don't have the value of one of the sides, we don't have enough information to solve this problem. Consider the circle pictured below. Points A, B, and C all reside on the circle. AC and AB are perpendicular. What is the perimeter of the circle? Alright, so the key here is that we have two chords AC and AB that share a point A and they're perpendicular. So that actually means that CB is going to be a diameter. And there is a theorem to back that up. However, even if you don't know the theorem, if you simply look at the diagram on the ACT and are given the information that you're given, the only logical conclusion to reach is that you're going to have to use the Pythagorean theorem and assume that this is a diameter. So even if you're not 100% sure that you get a diameter when you have two chords that share a point that are perpendicular, you should be able to reason that you probably can get the diameter using the Pythagorean theorem by drawing in that triangle. So once you calculate the diameter, you should be able to calculate the perimeter of the circle. So let's use the Pythagorean theorem. We have 6 squared plus 6 squared equals c squared, so your diameter is going to be 6 square root of 2. Alright, now we just need to plug in 6 square root of 2 into the formula for perimeter, which is pi times diameter. So we have 6 pi root 2 is our answer.